Okay.
Okay, so this is the second reading that we've done of this book, Breaking the Habit of Being Yourself by Dr. Joe Dispenza. We are on chapter 1, entitled The Quantum You. Okay.
The quantum you. Early physicists divided the world into matter and thought, and later matter and energy. Each member of those pairs was considered to be entirely separate from the other, but they're not. Nevertheless, this mind-matter duality shaped our early worldview, that reality was essentially predetermined and that people could do little to change things through their own actions, let alone their thoughts. Fast forward to our current understanding that we are part of a vast invisible field of energy, which contains all possible realities and responds to our thoughts and our feelings. Just as today's scientists are exploring the relationship between thought and matter, we are eager to do the same in our own lives. And so we ask ourselves, can I use my mind to create my reality? If so, is that a skill that we can learn to use to become who we want to be and create the life we want to experience? Let's face it, none of us is perfect. Whether we'd like to make some changes to our physical self, emotional self, or spiritual self, we all have the same desire. We want to live life as an idealized version of who we think and believe we can be. When we stand in front of the mirror and look at our love handles, we don't just see that slightly too podgy vision reflected in the glass. We also see, depending on our mood that day, a slimmer, fitter version of ourselves or a heavier, chunkier version. Which of our images is real? When we lie in bed at night, reviewing our day and our efforts to be more tolerant, less reactive person, we don't just see the parent who lashed out at our child for failing to quietly and quickly submit to a simple request. We envision either an angelic self whose patience was stretched like an innocent victim on the rack of a hideous ogre laying waste to a child's self-esteem. Which of those images is real? The answer is all of them are real, and not just those extremes, but an infinite spectrum of images ranging from positive to negative. How can that be? For you to better understand why none of those versions of self is more or less real than the others, I'm going to have to shatter the outmoded understanding about the fundamental nature of reality and replace it with a new one. That sounds like a major undertaking, and in some ways it is, but I also know this. The most likely reason why you were drawn to this book is that your past efforts to make any lasting change in your life, physical, emotional, or spiritual, have fallen short of the ideal of yourself that you imagined. And why those efforts failed has more to do with your beliefs about why your life is the way it is than with anything else, including a perceived lack of will, time, courage, or imagination. Always, in order to change, we have to come to a new understanding of self and the world so that we can embrace new knowledge and have new experiences. This is what reading this book will do for you. Your past shortfalls can be traced at their root to one major oversight. You haven't committed yourself to living by the truth that your thoughts have consequences so great that they create your reality. The fact is that we are all blessed. We all can reap the benefits of our constructive efforts. We don't have to settle for our present reality. We can create a new one whenever we choose to. And we all have that ability because, for better or worse, our thoughts do influence our lives. I'm sure you've heard that before, but I wonder whether most people really believe this statement on a gut level. If we truly embraced the notion that our thoughts produce tangible effects in our lives, wouldn't we strive to never let one thought slip by us that we didn't want to experience? And wouldn't we focus our attention on what we want instead of continually obsessing about our problems? Think about it. If you really knew that this principle were true, would you ever miss a day in intentionally creating your desired destiny? To change your life, change your beliefs about the nature of reality. I hope this book will shift your view of how our world operates. convince you that you are more powerful than you knew, and inspire you to demonstrate the understanding that what you think and believe has a profound effect on your world. Until you break from the way you see your present reality, any change in your life will always be haphazard and transitory. You have to overhaul your thinking. You have to overhaul your thinking about why things happen in order to produce enduring and desired outcomes. To do that, you'll need to be open to a new interpretation of what is real and true. To help you shift into this mode of thought and begin to create a life of your choosing, I have to begin with a bit of cosmology, the study of the structure and dynamics of the universe. But don't be alarmed, we're merely going to skim through the nature of reality 101 and how some of our views about it have evolved to reach our present understanding. All of this is to explain, of necessity, in a brief and simple way, how it is possible that your thoughts shape your destiny. This chapter just might test your willingness to abandon ideas that have, in a sense, been programmed into you for many years on a conscious and subconscious level. Once you gain a new conception of the fundamental forces and elements that constitute reality, it won't fit into that old perception in which the linear and the orderly rule the day. Be prepared to experience some fundamental shifts in understanding. In fact, as you begin to embrace this new outlook, your very makeup as a human being will change. It's my wish that you will no longer be the same person you were when you began. Obviously, I'm about to challenge you, but I want you to know that I'm entirely empathetic because I too have had to let go of what I thought was true and leap into the unknown. To ease into this new way of thinking about the nature of our world, let's see how our worldview was shaped by the early belief that mind and matter were separate things.
Let me stop this.
Always matter, never mind. Always mind, never matter. Connecting the dots between the outer physical world of the observable and the inner mental world of thought has always presented quite a challenge to scientists and philosophers. To many of us, even today, the mind appears to have little or no measurable effects on the world of matter. Although we'd probably agree that the world of matter creates consequences affecting our minds, how can our minds possibly produce any physical changes affecting the solid things in our lives? Mind and matter appear to be separate. That is, unless there's a shift in our understanding about the way physical solid things actually exist. Well, there has been such a shift, and to trace its beginnings, we don't have to go back very far. For much of what historians consider modern times, humanity believed that the nature of the universe was orderly and thus predictable and explainable. Consider 17th century mathematician and philosopher René Descartes, who developed many concepts that still have great relevance to mathematics and other fields. Does I think, therefore I am ring any bells? In retrospect, however, one of his theories ultimately did more harm than good. Descartes was a proponent of the mechanistic model of the universe, a view that the universe is controlled by predictable laws. When it came to human thought, Descartes faced a real challenge. The human mind possessed too many variables to neatly fit into any laws. Since he couldn't unify his understanding of the physical world with that of the mind, but he had to account for the presence of both, Descartes played a nifty mind game, pun intended. He said that the mind was not subject to laws of the objective physical world, so it was completely outside the bounds of scientific inquiry. The study of matter was the jurisdiction of science. Did you understand what that meant?
Mm-hmm.
Billa?
Let's stop.
The study of matter was the jurisdiction. When it came to human thought, Descartes faced a real challenge. The human mind possessed too many variables to neatly fit into any laws. Since he couldn't unify his understanding of the physical world with that of the mind, but he had to account for the presence of both, Descartes played a nifty mind game, pun intended. He said that the mind was not subject to laws of the objective physical world, so it was completely outside the bounds of scientific inquiry. The study of matter was the jurisdiction of science, always matter, never mind, whereas the mind was God's instrument, so the study of it fell to religion, always mind, never matter. Essentially, Descartes started a belief system that imposed a duality between the concepts of mind and matter. For centuries, that division stood as the accepted understanding of the nature of reality. Right. Helping to perpetuate Descartes' belief were the experiments and theories of Sir Isaac Newton, the English mathematician and scientist. Not only solidified the concept of the universe as a machine, but he produced a set of laws stating that human beings could precisely determine, calculate, and predict the orderly ways in which the physical world would operate. According to the classical Newtonian physics model, all things were considered solid. For example, energy could be explained as a force to move objects or to change the physical state of matter. But as you will see, energy is much more than an outside force exerted on material things. Energy is the very fabric of all things material and is responsive to mind. By extension, the work of Descartes and Newton established a mindset that if reality operated on mechanistic principles, then humanity had little influence on outcomes. All of reality was predetermined. Given that outlook, is it any wonder that human beings struggled with the idea that their actions mattered, let alone entertain the notion that their thoughts mattered, or that free will played any part in the grand scheme of things? Don't many of us still labor today, subconsciously or consciously, under the assumption that we humans are often little more than victims? Considering that these cherished beliefs held sway for centuries, it took some revolutionary thought to counter Descartes and Newton. Einstein, not just rocking the boat, rocking the universe. About 200 years after Newton, Albert Einstein produced his, sorry, just one second, I've just lost the thing. Sorry, I'm going too fast.
Page 28.
No, it's just went too far. About 200 years after Newton, Albert Einstein produced his famous equation E equals mc squared, demonstrating that energy and matter are so fundamentally related that they are one and the same. Essentially, his work showed that matter and energy are completely interchangeable. This directly contradicted Newton and Descartes and ushered in a new understanding of how the universe functions. Einstein didn't single-handedly crumble our previous view of the nature of reality, but he did undermine its foundation, and that eventually led to the collapse of some of our narrow, rigid ways of thinking. His theories set off an exploration of the puzzling behavior of light. Scientists then observed that light sometimes behaves like a wave when it bends around a corner, for example, and at another time it behaves like a particle. How could light be both a wave and a particle? According to the outlook of Descartes and Newton, it couldn't. A phenomenon had to be either one or the other. Quickly, it became clear that the dualistic Cartesian Newtonian model was flawed at the most basic level of all, the subatomic. Subatomic refers to the parts, electrons, protons, neutrons, and so on, that make up atoms, which are the building blocks of all things physical. The most fundamental components of our so-called physical world are both waves, energy, and particles, physical matter, depending on the mind of the observer, and we'll come back to that. To understand how the world works, we had to look to its tiniest components. Thus, out of this particular experiments, a new field of science was born called quantum physics. Shall I carry on?
Alice, you good?
Sorry? The solid ground we stand on isn't. This change was a complete reimagining of the world we'd thought we lived in, and it led to the proverbial rug being pulled out from under our feet. Feet we used to think were planted on solid ground. How so? Think back to those old toothpick and styrofoam ball models of the atom before quantum physics came along. Before quantum physics came along, people believed that an atom was made of a relatively solid nucleus with smaller, less substantial objects either located in or around it. The very idea that with a powerful enough instrument we could measure, i.e. calculate the mass of, and count the number, the subatomic particles that made up an atom made them seem as inert as cows grazing in a pasture. Atoms seem to be made of solid stuff, right? So the classical atom, the old school classical Newtonian version of an atom, focus is primarily on the material. Nothing could be further from the truth as revealed by the quantum model. Atoms are mostly empty space. Atoms are energy. They think about this. Everything physical in your life is not solid matter. Rather, it's all fields of energy or frequency patterns of information. All matter is more nothing, energy, than something, particles. So the quantum atom, tiny nucleus, and the electron cloud. The new school quantum version of an atom with an electron cloud. The atom is 99.99999% energy and 0.00001% matter. It's just about nothing materially.
I'm going to stop this just a second.
It's nothing.
It's nothing. And that's why this is the most realistic model. It is no thing materially, but all things potentially.
Potentially. Oh, okay.
Yeah.
Okay. Shall I start reading again? Oh,
sure.
We're on.
I just started recording when you were talking about the picture. Okay.
Oh, okay. Another puzzle, subatomic particles and larger objects play by different rules. But this alone wasn't enough to explain the nature of reality. Einstein and others had another puzzle to solve. Matter didn't always seem to behave in the same way. When physicists began observing and measuring the tiny world of the atom, they noticed that at the subatomic level, the fundamental elements of the atom didn't obey the laws of classical physics the way that larger objects did. Events involving objects in the large world were predictable, reproducible, and consistent. When that legendary apple fell from a tree and moved towards the center of the earth until it collided with Newton's head, its mass accelerated and with a consistent force. But electrons as particles behaved in unpredictable, unusual ways. When they interacted with the nucleus of the atom and moved toward its center, they gained and lost energy, appeared and disappeared, and seemed to show up all over the place without regard to the boundaries of time and space. Did the world of the small and the world of the large operate under very different sets of rules? Since subatomic particles, like electrons, were the building blocks of everything in nature, how could they be subject to one set of rules and the things they made up behave according to another set of rules? Shall I carry on? Yep. Shall we record? Okay. From matter to energy, particles pull off the ultimate vanishing act. At the level of electrons, scientists can measure energy-dependent characteristics, such as wavelength, voltage potentials, and the like. But these particles have a mass that is so infinitesimally small and exists so temporarily as to be almost non-existent. This is what makes the subatomic world unique. It possesses not just physical qualities, but also energetic qualities. In truth, matter on a subatomic level exists as a momentary phenomenon. It's so elusive that it constantly appears and disappears, appearing into 3 dimensions and disappearing into nothing, into the quantum field. in no space, no time, transforming from particle matter to wave energy and vice versa. But where do particles go when they vanish into thin air?
Again. And I'm going to stop this right here, one, because of time, and two, to let us digest what we've heard so far. So we'll pick up next time with that question, where the question is, what happens when these infinitesimally small particles disappear into nothing? And his question is, where do particles go when they vanish into thin air? So we'll start that next time.
Great.